started the gravitation lesson. In that we have completed the free fall concept, right? So what is called as a free fall? Any object which is falling under the earth's surface or which is falls towards the earth's surface because of a gravitational force, that fall is called as a free fall. I have told in the previous class, right? So in the today's class we are going to start with the acceleration due to gravity. Before that I will tell you one experiment. It is done by the Galileo Galilei. Okay, consider two objects. One is a stone, okay, iron stone or anything. Okay, consider one iron ball. Okay, consider one iron ball and another one is a paper. So when you dropped both the objects from the certain height, which object will falls? Which object falls easily on the earth's surface? Yes, the objects which is having a higher mass will reach the earth's surface soon. In these cases, iron ball has a large mass compared to paper. So these iron balls reach the earth's surface faster than the plain paper. This is done because the air resistance also supports these objects to fall on the earth's surface. So what is air resistance? Air resistance means the surrounding air which will help to fall the objects on the earth's surface. Okay, so Galileo done the experiment that in the Tower of Pisa. In that what I observed, the objects which are having a different masses. Okay, he considered the three balls of a different masses, and when he falls those three objects from the top of the Tower of Pisa, the objects means all the three balls will reach the earth's surface at the same time. Why? Because it is happened. This is because happens the air resistance offered to those objects is negligibly zero. Okay, either we can have said there is no any air resistance in the Tower of Pisa. So those three balls will reach the earth's surface at the same time. So from this experiment he concluded that whether a paper or a iron ball or the larger mass object or a small mass object, when they are leave from the some certain height, they will reach the earth's surface without any means there is no any difference in the time. They will reach the earth's surface at the same time. This is because there is no air resistance. Means when there is no air resistance, the objects having a different masses will reach the earth's surface. So Galileo called this as a acceleration due to gravity. So what is called acceleration due to gravity? Any object which is falling towards the earth's surface because of acceleration exerted by the object, that we call it as a acceleration due to gravity. So how much value of this earth surface having the acceleration means any object which is required acceleration to reach the earth surface is 9.8 meter per second square. So it is denoted by a small letter G. Okay, that is 9.8 meter per second square. That this is the acceleration. Okay, any object which is falls from the certain height, it requires 9.8 meters per second square of acceleration to reach the earth's surface. Okay, whether the object is a higher one, means it is having a large mass or a small mass, whatever, the acceleration required for that body is 9.8 meter per second square. So the value of acceleration due to gravity is 9.8 meter per second square, which is different from a universal law of gravitation. The constant value, that is nothing but the capital G, and this one are a different one. So we are in the next session we are going to derive the this value using the expression of acceleration due to gravity. Before that, what is the definition of that one is the acceleration with which a body falls towards the earth due to the Earth's gravitational pull, that is known as the acceleration due to gravity. It means that when we neglected the air resistance, many two objects which are falling towards the Earth's surface, they are falling due to the constant acceleration. Okay, so there is no any mass of the object or any force, but they are falling due to the gravitational pull towards the Earth center. So that is called as acceleration due to gravity. So this acceleration due to gravity depends upon the acceleration of the object, and we have a free fall. So what is the definition of free fall? Any object which is falling due to only the gravitational force, okay, only gravitational force, that is falling towards the Earth's surface, that we call it as a free fall. Okay, so we are going to derive the expression for a gravitational acceleration due to gravity. So here we are deriving the expression for a acceleration due to gravity. If I ask to derive the expression for acceleration due to gravity, then you have to solve this. Okay, so first one is a consideration. What we have to consider here? Consider a body of mass m, small m. Okay, any object having a mass m near the surface of the Earth. Okay, the force acting on a body is the gravitational force. The object is falling, and which is acting on that body is gravitational force of the Earth. Okay, the magnitude of the gravitational force acting on the body due to Earth's surface, that is given by using the universal law of gravitation. Okay, so we write gravitational force F is equals to G into M into small m divided by r square. Okay, here we consider the 1 m as the mass of the Earth. Why? Because the object is falling towards the Earth surface and it is having a mass, means Earth having a mass, that is a capital M. Here I write m is a mass of the Earth, and which is falling on the Earth surface. We are considering the radius of the Earth. Why? Because any object which is falling on Earth's surface which is very negligible compared to the radius of the Earth. That's why we are considering the radius of the Earth. Therefore, the equation is capital F is equal to G into capital M small m divided by r square. So, and this gravitational force F produces the acceleration which is equal to small g. Okay, means that gravitational force will produce the acceleration that we taken it as a small g in the body of the mass m. Okay, means the acceleration which will acting on the body of mass m, that will be produces the gravitational force. Okay, we are considering here the Newton's second law of motion. Okay, that is F is equals to m into a. Using this equation, we are deriving the acceleration due to gravity. Okay, here this acceleration is replaced by the acceleration due to gravity which is produced by the body of mass m. Okay, that is F equals to m into a. A is acceleration which is replaced by a small g. Then okay, this is equation 1, and universal law of gravitation is equation, this is equation 2 and that is equation 1. Here the forces are, both the forces are gravitational force. We are equating those from 1 and 2. We have m into g. This is equal to this value. Okay, when this mass is get cancelled, we left with small g is equal to capital G into m divided by r square. So from this acceleration due to gravity, we can say that this is independent of the mass of the object. Okay, here there is no any mass term, right? Here we are only having a mass of the Earth. Okay, or we are doing it for any other planets or any other celestial bodies. We are considering they will act on the mass of that body. But here the mass of the any living objects which on the Earth surface we are not considering. Okay, you got that? So acceleration due to gravity is equal to capital G, that is a universal law of gravitation, and this is a mass of the Earth and r is the radius of the Earth. Here here acceleration due to gravity not depend on a mass of the body. Okay, using this equation only we are going to derive the acceleration due to gravity of the earth. Okay, so there are some factors which are depend upon the acceleration due to gravity. So what are those factors? From this equation we can say that. So here we are considered the small g equals to capital G into m divided by r square. This gravitational force is directly proportional to capital M because this g is a universal constant and we does not consider this constant, and this gravitational force, the acceleration due to gravity is inversely proportional to radius of the, means a square of the radius of the earth. So the two factors which depend upon the acceleration due to gravity are, first one is a mass of the earth and which is directly proportional to acceleration due to gravity, and second one the radius of the earth, means the square of the radius of the earth is inversely proportional to acceleration due to gravity. These are the two factors on which the acceleration due to gravity depends. Using the value of mass of the earth and radius of the earth and the universal law of gravitation constant value, we are going to calculate the acceleration due to gravity. Okay, here I written the gravitational constant value, that is 6.654 into 10 raised to minus 11 Newton meter square per kg square, and m is the mass of the earth, that is me, 5.98 into 10 raised to 24 kg, and r is the radius of the earth, that is 6.4 into 10 raised to 6 meters, and that is a RE. We have to put these value in this equation. So I have written here the constant value, universal of gravitation constant, and mass of the earth and radius of the earth. By cancelling we will get the value which is equals to 9.8 meter per second square. Okay, you should mention the unit, otherwise the value will be cancelled. Okay, it will be wrong. So the unit of the acceleration due to gravity is a meter per second square. Cancel here. Here it will be a Newton meter square per kg square, and it is a kgs, and this is a meter square. When we are cancel those, we will left with the Newton per kg. So the value of a Newton and the kgs will cancel and left with the meter per second square. So this is the value of acceleration due to gravity on the earth's surface. You have to calculate the acceleration due to gravity of the moon. How will you do it? By writing the mass of the moon and radius of the moon in this equation, and the value for this gravitational constant will not changes on the whole universe. It will be a constant. If you consider a moon or any other planet, this value, gravitational constant value, does not changes. Okay, so same gravitational constant value, and in place of m you have to put the mass of the moon, and in place of r you have to put the radius of the moon. By using these values you have to tell me the acceleration due to gravity on the moon surface. In the next class I will going to start with the mass and the weight and then the continuation topic. Okay, thank you for watching the video. I will give you the mass and the radius of the moon. Here I have given you the mass of the moon, that is 7.4 into 10 raised to 22 kgs, and radius of the moon is 1.75 into 10 raised to 6 meters. Sorry students, extremely sorry. The universal gravitational constant value 6.673. I have written the 6.654, but the value is 6.673. So do the correction that 6.673 into 10 raised to minus 11. Here also same. Okay, in the next class I will start with the mass and the weight and the difference, and I will also tell the difference between the acceleration due to gravity and the universal law of gravitation. Thank you for watching the video.